Hello friends. So this is a Harvard physics problem series and this problem is called sliding along a plane. The problem says a block is placed on a plane inclined at angle theta. The coefficient of friction between the block and the plane is mu, which is equals to tan theta. The block is given a kick so that it initially moves with a speed v horizontally along the plane, and that is in the direction perpendicular to the direction pointing straight down the plane. What is the speed of the block after a very long time period? So this is a very beautiful problem. So let us try to see what is happening here. So let's say this is a line that is pointing along the plane. So this block, let's say initially this block is somewhere here, and this block has been given a velocity in this direction v. Let's call in this case v naught. So let's say this velocity is v naught. So initially a v naught velocity is given to this block. Now the questions ask, what is the speed of block after a very long time period? So let us first try to find out what will happen to this ball. So this ball will move in this direction. But now what the trajectory, how its trajectory will look like? So if you see on this ball, what are the forces that is acting? So we can show the forces that is acting on this ball. So this is line and this is another line. So this is the same thing that I am making. So this angle is theta. So what we are doing is we are looking from this side. This is the side view, you can say. So block is somewhere here. What are the forces that is acting? Mass times z that is acting in this direction, and this angle will be 90 minus theta. And then on this block you will have a component of this mg that will be mg sin theta, and in this direction you will have mg cos theta, and in this direction you will have normal reaction, basically perpendicular. So this will be the normal reaction that will act in this direction. And if you give this ball a velocity like this, there are two forces. One force, so let's say after some time this block is somewhere here. Why this is so? Because there is a driving force in down the plane. So there will be an increase in the velocity in the down the plane because there is a driving force. So after some time, initially there is no velocity in this down the plane, but after some time there will be a gain in the velocity in the down the plane. So velocity in this direction will increase, and that's why this block will follow a trajectory something of this kind. So this block will follow some of this kind of trajectory because there is an increase in the velocity down the plane. So let's say at certain point of time this block is here. What will happen to this velocity? This velocity will reduce. Why? Because there is a friction force that is acting on this block. So friction force will act in this direction. So the velocity, this velocity, or you can say speed, a speed will decrease. So initially this was v naught, but now it will not remain v naught, it will be v. So a speed will decrease. So we can say a speed will decrease, or we can write it here. A speed of block will decrease. And what about the speed, the component of this speed, or you can say component of this velocity along the plane? So let's call this direction is a bi-direction. So component of this speed in the bi-direction, this speed, what will happen to this? So this speed will increase because there is a driving force mg sin theta. So we can say component of velocity in the bidirection, component of velocity in bidirection, which is v by, will increase. So let us try to see this. So if you see this one, and this case, there will be a friction force, that is F. So on this block, basically, there will be a friction force. So on this block, there will be a friction force that is acting in this direction. So the magnitude of this friction force will be what? So there will be a friction force that is acting on this ball in this direction, or this block in this direction, and the magnitude is F. And F will be what? So friction force will be mu times normal reaction. Now in this figure, you can say normal reaction is nothing but mg cos theta. So friction force is equals to mu times n, that is mu times mg cos theta. But in the question it is given mu is equals to tan theta. So tan theta times mg cos theta. So this is basically mg sin theta. So this friction force which is equals to mg sin theta, this will try to decelerate. So this is responsible for decrease in a speed. So this is responsible for decrease in a speed. And what is responsible for increase in the speed? So along the bidirection mg sin theta, this mg sin theta will increase the speed. So once again, so the force that is responsible for increase is also mg sin theta. So v by will increase due to mg sin theta. So this is very important here. Now see, the force that is trying to increase the speed, component of this total velocity in the bidirection, that is v by, is mg sin theta. And the force that is trying to reduce this velocity is also mg sin theta. This means what will happen? The amount by which this speed, that is v, is decreasing is same as the amount by which this speed is increasing. So I can say increase in v by is same as decrease in v. This means what? If you have two quantity, and in one quantity increase is same as the reduction in the next quantity. So what will happen? So you can say the sum of these two quantities is constant. So we can say in this case v plus v by is constant. So this is very important point here. Let's call this constant is c. So now what we have? We have v plus v by is some constant c. So this is the result we have. Now how we can find c? So initially at t is equals to 0, what we have? We have only one velocity, and that is v naught. Initially we have only one velocity, v naught. There is no velocity in the bidirection. So initially we have only v naught. So v is equals to, initially v is equals to v naught, and v by is equals to 0. So if you plug this, so what you can have? You can have v0 plus 0 is equals to c. This implies c is equals to v0. C is equals to v0. So what we can say is, so now my equation becomes v plus v by is equals to c. Now the question says, what will be the velocity after a long time? So let us try to understand. What will happen? As time increases, velocity, or you can say the block, will be moving parallel to this line. So this will be moving along this line, which is basically parallel to this line. So there will be one velocity, or you can say the total velocity will be along this line, along Vy. So all the velocity will be along bidirection, because this speed will reduce, and finally at one time what will happen, the friction force that is acting mg sine theta and the driving force that is acting along this line, that is also mg sine theta. So in equilibrium what will happen, these two forces will basically equate to each other and the ball will be moving along the bidirection. So you can say the total velocity v, which will equals to v by. So you can say as t tends to infinity, the total speed, or you can say the total velocity also, the total velocity is in bidirection. Total velocity is in bidirection. This means what? V is equals to V by. So if I plug this value in this equation, what we will have? We will have V plus V is equals to constant C, and C we already know that is equals to V naught. So from here we can say V is equals to V naught by 2. So after a long time, this block will be moving with a terminal speed, and the terminal speed will be half of the initial speed, that is V naught by 2. Now this was a very beautiful problem, and the main point in this case is you have to see the friction force and the driving force both are equal. That's why this all happening, because at the end of the day, what will happen, the driving force that is acting along the bidirection, that is acting along the plane, is equals to friction force, which is also equals to mg sine theta. So I hope you understood this problem, and if you like this problem, please like, share and subscribe so that I can make few more problems. Thank you so much.